I can start my presentation, madam?
Yes, sir. Yes, sir. You can start, sir. Thank you, sir.
Yeah. Shalini, you can see my PPT now?
Yes, sir. It's visible, sir.
With the pointer?
Yes, sir.
Fine.
Okay.
Yeah, good morning to all, my dear friends. Respected head of the department, Dr. Professor Malati, and my dear student and friend Prabhu and Mrs. Prabhu, the coordinator of this program, and senior faculty members and professors in the Sona College of Technology, participants from various parts of our country, even abroad also. My dear students and friends, good morning to all. It is my happy and prestige and privilege to share some topic regarding that artificial neural network or machine learning algorithm in the field of civil engineering. Within the stipulated time, I want to conclude my PPT. My allotted time it's around 11. So try to accommodate and finish my PPT within the right time. So I'm the Board of Studies member for Sona College of Technology. I know well about that. What is the development? What is that technology transferring from Sona Institute of Technology to the industry? And what is the technologies bring down from industry to institute also? I am known very well because of Board of Studies member. Every time the madam presenting well regarding the development of department also. My best wishes and congratulations to the team behind of madam and the team leader madam also. So for these wishes, I want to start my presentation today. Shalini, my voice audible?
Yes, sir. It's audible, sir.
Fine. Okay, today I want to discuss about that prediction of building strength using machine learning algorithm. So at present, the title given by Sona College of Technology, Department of Civil Engineering, Digital Transformation, Trends in Construction Technology. So my topic may not be exactly deals with the digital transformation, but little bit related to um, digital transformation, trends in construction technology. What I want to today speak with another 1 hour means, so how to predict the building strength in particular. I am working in the beam column joint, seismic vulnerability of that. So using that any machine learning algorithm, how I can calculate or how I can find that efficiency of my joint. Suppose I want to particularly find some strength in case of bending, shear or joint strength or member ductility or whatever it may be. So how we can calculate or how we can assess this kind of parameter using machine learning algorithm. This is the today's topic. So now you can remember these two figures. At the end of this presentation, you maybe know what is the figure is given by myself in a slide 1. So this is the some algorithm inside for optimizing or optimizing of that result. So first I want to give some few introduction about that beam column joint. So most of them well known about that, so less of them is not aware about that. During the earthquake, the beam column joint is a highly vulnerable, we know all. For example, you look at this building, suppose this is taken as a beam. So this is the column, beam, and this also is column, right? So in the column, no damages, beam also no damages, but you look at the joint, it was damaged. Yeah, clearly indicated here also, this is the beam, column, column, beam. From here to here no breaking. But you take the joint have the failure. Almost all the building like this. So we want to take more attention regarding in that beam column joint during the earthquake resistance structures. These are the another few examples of beam column joint failure. You look at here. So the beam column joint is a highly vulnerable and critical element in that building structure systems or multi-story building system. Here also you notice the all. So this is a different type of failure. Then what do as per the code we are using that weak beam strong column concept. So first the beam tends to failure. After that column take care of the load, then load transfers to the footing. This kind of mechanism assuming we design the structures. So now we are working in that another aspects. So not only need the weak beam and strong column concept. In between we have some technologies or philosophy at present need. So what are the things? Now I come to that beam column joint as per ACI 352R2. Beam column joint is defined as the portion of the column within the depth of the deepest beam in frames into the columns. So different beam column joint we have interior, exterior, corner, then roof top interior, roof exterior, roof corner, so on so etc. So what is the problem in the interior beam column joint? So not much more problems related to that. For example, the beam column joint, the column experienced axial load like this. The beam have moment this direction. This also moment here, moment here, moment. The span in this direction same. These two balanced. So here also the beam is the same span, same load. This also no problem. These two moment counteract. So not much more effect is getting down for this joint. So it's quite less vulnerable. You can see in that in the outer column only experienced more due to the earthquake. Now I come to this exterior beam column joint. Suppose this span is this span and this span is the same length, same load. So this moment is nullified. So the column experienced vertical force, then we have the moment. So this moment it's not balanced. So this is the problem. Then here is the corner joint. This also having problem here moment. But the corner joint in case of the in a rectangular building only 4 corners we have. The less number of exterior corner beam column joint. But you can take the building more number of exterior beam column joint and interior beam column joint also. The interior is very less, then exterior is the highly vulnerable. Again, same kind of things is happening in the roof also. So most of the researchers doing in this exterior beam column joint, they remove this beam. Simply we can take like a T shape of beam column joint like this. So this is the column, this is the beam. This is simple beam column joint they are using. Now, what is the problem in beam column joint? The research community has not yet understood the full behavior of beam column joint and beam column connections. So I am talking only about the vertical force and moment. So this same beam column joint is subject to earthquake. So n number of forces acting here, even tension, compression, bending in upward direction, bending, hogging, bending and sagging. So this lot n number of forces acting, this still we need the more exploration need behavior of beam column joint. Inconsistency in the current standard codes as per Indian codes, as per American codes and European code, the inconsistency in the current standard codes. So we are design this member beam column, no design to design the beam column joint because this is a highly vulnerable. Then joint performance, the very less people considering the joint performance in terms of bond between the beam bars and the concrete need to be investigated. The influence of column axial load on the joint shear strength is conventional aspect, controversial aspect. Assumptions of ACA, American Concrete Institute, American Society of Civil Engineers Committee, 352 and ECS, EC8 methods, influence of the stirrups, beam, longitudinal reinforcement ratio, joint aspect ratio on the joint shear strength. Then lack of significant parameters in the formulation, the technique of artificial intelligence to find the joint shear strength not explored much. So lot of complication we have in that beam column joint with respect to load carrying mechanism, the jointing between that beam and column, then shear reinforcement, then shear force and everything, lot of factors involving in that beam column joint. That's we want to take our care of more. The lack of availability of holistic numerical models in this depth of treatment in the standard text. So we need some methods to find the strength or joint strength of beam column joint. For example, this is the behavior of beam column joint in the earthquake. A earthquake is acting for the load, this ground shakes like this, the force is acting like this. So in the first circle, the beam is moving like this in the opposite direction. In this direction it will come. So now you look at this beam column joint, how that sagging as well as a hogging in that beam tends to move. We can experience a cyclic loading to this joint is subjected to failure. For that, joint is should be rigid. The sagging moment on one side and hogging moment on other side. Here, hogging and sagging, the same frame experienced both hogging as well as sagging moment. The seismic design philosophy of strong column weak beam concept at present using. So this is somewhat it's okay. Previously no concepts of the weak beam strong column concept. At present we are using this concept. The work done in the form of excessive inelastic or plastic irreversible deformation or plastic hunch by the lateral earthquake forces on account for the stored strain potential energy due to the lateral stiffness is termed as the seismic deposition capacities. The high bending moment on the beams result in the higher shear the dim to the joint. These are some mechanisms, sway mechanism, then right to left, left to right. Now, the beam strength, so previously the columns, at present, the column strength is greater than beam strength. Column strength is greater than the beam strength at present theory we are using now. Now, at present, I want to change a little bit. The joint strength is greater than the column strength. Joint strength is greater than the column strength, or otherwise, strongest joint, strongest column, weak beam design. So this kind of method is coming in the future. We can reduce this beam column joint failure and we can reduce this damages of the building the strongest joint, strong column, weak beam concept. So for this kind of things, we need some methodology, we need some numerical modeling, then only we go for implement this kind of concept in the field also. So we are working in this area. Now, this is the exterior beam column joint of free body diagram. I can consider the forces of a free body diagram. So this is the exterior beam column joint. I have that load, the axial load opposite reaction, then moment due to the eccentricity of the column, then shear in that column, then the moment and vertical force, that is a shear. So the single joint, we have that M, V, S, H, then V, M, V, and all those things. So we have moment, force, that is a tension, compression will come, then shear force, all these things available. As a problem at present is in the civil engineering, no, compression, tension, moment, shear force, another one is a torsion. This is the mostly we are using this in the civil engineering field. We can design the structure by compression, tension, moment, shear, torsion, so on so. So this beam column joint itself, we have all the forces. That is the complexity of the beam column joint. Now come to that interior beam column joint. These are the forces, the vertical force here, the moment, shear, so on so. This is exterior beam column joint. Now this is the complexity of beam column joint. Then free body diagram and bending moment and shear force diagram of exterior or interior beam column joint within the point of contraflexure of sway to right to sway to right. So we have we can take that beam column joint alone. This is a beam, right here. So the beam column joint, we have the tension, compression, moment, the shear here. In addition, that vertical forces also. So this is the condition subject to static loading. Static loading. Now the same things extended for dynamic loading or seismic loading. The beam and column, it tends to rotate. It's initially, it may be like this. If earthquake comes, it may be rotate like this, rotate like this. So after this, again it's coming back, it's going up and down. Initially the first mode shape, we can have tension at the top, compression at the bottom. So if the structure is moving from left to right, this one, then right to left, this ulta, T became a C, C became a T. So it is experienced both compression tension, hanging as well as a sagging moment, shear also changing. Lot of complication in the beam column joint, even structure said to be a dynamics. So this is the forces acting in this exterior beam column joint. This is forces acting in this interior beam column joint. These are the corresponding bending moment. Here we have the some twisting moment, plastic hinges like this kind of things formed in the beam column joint. I want to add more about that shear in the beam column joint. Most of the people maybe know about that. The shear is the predominating factor to failure the or contributing failure to the beam column joint. For this, this is the joint exterior, sorry, interior, exterior, and corner. One is a column shear, another one is a joint shear. Column shear, joint shear. We have the different formulae for different researchers, different code, different philosophy, different philosophy we have that. So I can take this column shear, another one is a joint shear. So we have a lot of data in the column shear, but less data is available in the joint shear. So I can relate to these two, column shear and joint shear. I can develop a numerical model. I can take this is the basic one, right? In addition that I add this and combine these two, I can get the new model. So what are the parameters to need for develop this model? What is the algorithm inside of this model? This kind of things I want to take more. So what I want to try to say here means in case of the column shear and joint shear, different people, different formulae is given to predict this column shear and joint shear. For example, as per IS 13920 part 1 and ACA 352R02, the interior beam column joint, exterior beam column joint and corner beam column joint, the column shear and the joint shear, this is the formula. Suppose you take this Murthy Professor CVR MIT et al. The column shear formula and joint shear formula is something different here. So some people consider the more parameter, some people consider less parameter, lot of deviation from their model. Then some limitations also with respect to interior, exterior or corner beam column joint. Suppose I want to take the interior beam column joint, we have the shear, tension and compression. This is simple model. Then exterior beam column joint, you have the tension, so no compression here. Here this is the corner beam column joint, we have the shear, no the load, we have the tension. So these are the some limitations and parameter considered for their own model. So this is the typical model available in Parley et al. The strut and the truss model. We can take this beam column joint as act as a strut. Strut means compression. Truss is the roof trusses. You can see that. So this kind of things. This area experienced the tension as well as compression, bending, shagging, bending, hogging. Then shear forces also acting x to y direction and y to x direction also. So for this, this is the complexity of the force acting in that beam column joint. This is the equivalent free body diagram. Free body diagram of stress level and all those things. Now I can take, in case of this is the compression, this is a tension. Now in this direction, it comes this compression, tension. Now I can take this shear also, this column compression here, column tension also. The shear force from here to here, then here to here, then here to here, from here to here. So you can look at this lot of complexity in nature. So we can consider as this equivalent to strut and truss model. So with respect to width, we can predict what is the strength of the beam column joint. So same kind of theory we are using in that portal frame also. For example, I can take this is the frame. I can apply the load in the horizontal direction, in this direction. So this is the plane. We have that tension as well as compression. Also along this we can have the shear forces also. It's coming this direction. So I can show some figure also here. This is the typical example for that concept. So truss model. So equivalently I can take this is the strut and truss model. The each and every model have a own explanation and own limitations also, that model. So for this kind of things, we have the n number of parameters, we have the n number of complexity and n number of conceptual controversies also. For that, we go for some numerical method or empirical method to find the solution of that particular problem. Then joint shear strength of interior beam column joint. We have the lot of formulas to calculate CT, VH, VJ, VC, so on. So for this figure, we can calculate and all those things. It's possible. So not only the researchers, the code also given a lot of provisions so that predicts the beam column joint. For example, IS 13920 VJC, it is the 1.5 AEF root of FCK for joints is confined by the beams on all four faces. That is the interior. Then it 1.5, 1.2 into AEJ root of FCK for joint is confined by beams on three faces for other joints. So this is the formula is given by IS 13920. Similarly, AC also is given formula to find the what is the shear strength. Then some Australian code also is given this formula. So in addition that we have the some empirical equations to find the joint shear joint strength in terms of joint type index, joint type index and joints strength. This is the Mehmet Yunal is given this empirical equations. Then another one is a Tunk et al is given the some empirical equations to find the joint shear. So still we have the lot of this is only standard the empirical equations and formulae given by the author, and the formula is formula given by code we discussed. So what do you learn from here? The different country, different author have the different approaches to find the joint shear strength or joint strength of beam column joint. They have a lot of deviations from this. So it's quite difficult to find the exact shear strength or joint strength of that beam column joint. So what we want to do, it means with respect to this available data in terms of author finding, in terms of empirical equations, in terms of literature review, we can formulate the new formulae to solve these kind of problems. So for that, machine learning is one of the leading and growing area to solve the complex problem also. So using the machine learning concept, how we can solve this our civil engineering problems. There is a common tool we can solve any problems like electrical, computer, data science, EC, traffic problem, everything. Simply I can tell now, in the olden days in our studies, we studied the computer programming. You can give the input command to the system, that is a command, input is a command, you do this, please do this like that, right? So I give the assignment, the students just write the assignment and submit output. So what we given, we give the input, it comes to the output. That is called as a input command, like a calculator, 2 into 2 equal to 4. I gave the input command 2 into 2, I can get that 4, that is the output. So this is one type of approach, that is the input command. Then at present the scenario is changed, not a input command, I want to give some input data. What is here? Input data. I want to multiply 2 into 2, 2 into 2 equal to 4. So for example, I want to don't give 2 directly. So 2 man purchased 1 apple each. 1 apple each. the each apple cost of 2 rupees. What is the cost of total cost of that apple? Understand? Now the input is given as a data, not a command. So we can give the data means we are thinking now. We are thinking. So one person get one apple, another person get one apple, then multiply by the cost each 2 rupees, each 2 rupees, 2, 2, totally 4 rupees. So the concept is this, the output is the same from here in this command input and input data. But here, without knowing, lot of learning happening inside. Lot of learning happening inside. So this is the at present technology. So we give the input data. We want to learn this. So this concept is called as a machine learning concept. So we can we can learn lot of things here. For example, I can take the bending moment, right? Bending moment or the simply supported beam at middle, m is equal to w l square divided by 8. Simply we can given, right? Now I can give that w in that range. It's a w is ranges from 0 to 3.5 Newton per kilonewton per meter. I'll give some condition also. If 0 not less than or greater than equal to 5 x, for example, x is greater than less than equal to 5. Then x is not less than or greater than 6, for example, length of the beam, like that. Then w as like a w. Then length also I give you the construction 0 to constraint 0 to, for example, 12 meter, right? So like that. So we can give this things like a data. It's learn the data, from that we can give the answer, right? So you maybe give the data in exactly what is that WL squared divided by 8. We can get the result also. Now you can get that, you can give this information with respect to data, with respect to the range from this to this, from this to this. So from this, you take all the data, analysis the data, they give the input. That is called as a machine learning, right? Then machine learning, deep learning, artificial intelligence, data science, computer science, and all this. This is the domain. Computer science, data science, artificial intelligence, and machine learning, deep learning. These are the things, right? So using this algorithm, I can develop this. I want to find this some better formulae to find the strength of the beam column joint. Now we are using that lot of regression analysis previous also, right? The degree 10 polynomial regression of 10 random points with a normal error. We have that any experimental we want to do it, we can compare with experimental data and theoretical data. We can plot in x direction and y direction. With respect to that r square value, we can conclude around 0.9. It may be best fit, and it's less than that. This may not be bit fit properly. It's a data deviate from the particular thing. More or less same kind of things we are using here also. So what is the machine learning model using that? The train set and test set. Train set and test set. We, for example, how you know, for example, I want to take a cell phone. You may be age of 5. You may not be know about this is the cell phone, right? The age of 6, 7, 8, 9, you should know this is the cell phone. How we know that? The frequently you can read or relook or using that, your mind or brain, it's told this is the cell phone like that. For example, initially you were thinking about the cell phone, it's like this, here and there randomly. Then ages increases, these points are coming close, I converging towards my cell phone, right? For a middle here. Again, here, I'll highly converge. This is conformed to the cell phone. How I can, it's confirmed this is cell phone. We have the previous datas, it's right. Previous datas, I come to the conclusion, this is the cell phone. So these are the things is doing that machine learning, right? Now, new terminologies understand the artificial neural network. What is a different machine learning techniques available? I am highlight today is artificial neural network, that is a ANN. One is labeled data. It means that what kind of inputs are given and what expected data should be output, and not any random value or member to be given as an input output without specifying it. That is called as a labeled data. It means that what kind of inputs given and what expected data should be output, and not any random value or number to be given as an input output without specifying it. Algorithm, a set of instruction. What is that algorithm? A set of instruction, rules, process, codes for solving the problem, for accomplishing a task. Hyperparameters, the line of code that act as the algorithm's setting, similar to the controls of the dashboard of an airplane, and cops use the term of radio frequency like that. Now, machine learning categories, right? So one is a description, a definition, types of problems. For example, supervised learning, unsupervised learning, reinforcement learning. Reinforcement learning. What is a supervised learning? Supervised learning is the method in which we teach the machine using the labeled data. Labeled data means what kind of inputs given and what expected data is coming down. For example, like a tutorial class. No? So the teacher teaches the students learning from the teacher is monitoring the students. We can come to that conclusion. Right? What kind of problems we can solve this supervised learning? The regression analysis, the classification, it's done by supervised learning, machine learning. Unsupervised learning, now at present this meeting, it's right. I'm not seeing anywhere any person, you may be listening or not listening. This is unsupervised learning. The machine is trained on this unlabeled data without any guidance. So randomly. So I am taking the class, you may not be aware, is may be aware, these kind of things. Then types of problems, association, clustering will happen to the unsupervised learning. What is the reinforcement learning means? Everything with a bounded one. It is the reinforcement learning when the agent interacts with its environment by producing the actions and discovers errors or rewards. So this is the reinforced learning, supervised learning, unsupervised learning. Mostly civil engineering problems, you can solve these kind of things, supervised learning. For example, I want to calculate approximate bending moment of this beam, simply supported beam. I know that what is that bending moment? This value, bending moment of value. So WL square by 8. you can find by mathematical model or experimentally we can find. So that is the supervised learning. So this is unsupervised learning. This is reinforcement learnings like that. Then the aim is forecast outcome it will come. Forecast outcome. Unsupervised learning discovers and underlying patterns, learn series of actions of that reinforcement. For example, I go for some path, it's not correct, I'll coming back, I'll go somewhere. This is approach is something different. Here approach is map labeled input, noun output, the understand the pattern and discover output, follow the trial and error method here. Then popular algorithms we are using for this supervised learning, linear regression, logistic regression analysis, SVM, KNN, ANN, decision trees, and random forecast. Then K means a priori, C means social network analysis, discounting, dimensional algorithm, and Q learning, etc. These are the things, popular algorithms. So we are mostly confined with supervised learning algorithm for the civil engineering field. Now I'll come to that artificial neural network. Artificial neural network. What is an artificial neural network? The neural network, we know that the artificial neural network, also known as neural network, is a popular supervised deep learning algorithm. Popular supervised deep learning algorithm for analyzing the data through the network decision layers. Network decision layers. ANN consists of interconnected decision functions known as nodes. ANN consists of interconnected decision nodes known as nodes, which interact with each other and through action like edges. For example, this is the one task. This is another one. Different tasks x1, x2, x3. So I can give the weightages to this W1, W2, W3, right? Multiply by W1 into x1, W2, W2, x2, W3, x3, W3. I can add some all those things. I can get that some output. So from this, what is the logic means? The how much this x1 letter to particular function is represented by means of weight W1, W2, W3 like that. Similarly, I can take the x2, the how much is related to W1, this is W3, W2 also. Similarly, here. Similarly, I can make it as n number of things I can solve. Finally, I can get that very good decision. Then we can store in our mind regarding some things, some terminologies. One is the input layer, hidden layer, output layer. These three is important. What is the input layer? Receives data, detects its futures, indicates futures. Hidden layer is analysis and process input futures. Output layer displays the final result. So the input layer, it's a data. Input layer is a data. The hidden layer analyzes the data. This is the learning side. Learning space. Learning space. Then with respect to this hidden layer, its output will come. This is the simple algorithms and topology available in that ANN. One is the input layer, hidden layer, output layer. So for this, input is a very important. What kind of input want to give to that ANN? With respect to the input only, the output it will come. It may be wrong means wrong, right means right. It will come like this. Then weights. A weight represent the strength of this connection between the nodes, like some short or importance factor. This is the weight. For example, I can take, I'll go back again, beam column joint. That's right. We have that moment, shear, tension, compression, so on so. Among these, which one is the predominating factor? Which one is the predominating factor? So which mode it tends to fail first? I can take with respect to the failure mode, right? First I given this moment of the beam, MB. Next, shear force of the beam, SFB. Next one is CB, column bending. Then column, shear force, so on so. Similarly, I can assign the weightages W1, W2, W3, W4, Wn up to like that. A weight is represent the strength of this connection between the nodes like sum of short importance factors. Bias, this is very, very important. Bias allows us to shift the activation function by adding the constant that is given in the bias in the input. So this is important. For example, y equal to mx plus c, mx plus c, right? X and y is the input variable. We can have m and c, right? M is the slope, and c is the intercept, right? So it gives this some residual. What is the remaining? It's maybe going through this junction or this going to some intercept, like kind of thing. Similarly, here also I can give this input, right? Multiply by weightage and particular function, and I have that biases, that is a constraints. So we can develop this model in the simple way in this mathematical form also. For this, we need some activation function. Activation function, it decides whether the neurons should be activated or not by calculating weighted sum of further adding bias with it. The purpose of the activation function is to introduce the non-linearity into the output of this neuron. That is the role of the activation function. I will tell you what is the activation function, how to represent it as a mathematical model. For example, free forward prediction prescription. For example, I can give this data, it's a x1, right? X1, x2. For example, I can say moment on the beam, right? This is moment on the column, like this, x1, x2. Now I can weightage this multiple of weightages W1, x1 to W1, x1 to W2, x2 into W1, x2 into W2. I can get that first things x1 into W1, W2 into x2. This is one. Then I can get that Z. Similarly, I can use some function is representing this process. It may be sine function, sigma function, tantric function, so on so. So what is the need of introducing this kind of function? For example, you may be recall in the finite element methods, for that complexities of things, we can represent in the shape functions, right? Similar kind of things we are using here. So for example, then we can take that x2, w2, we can get that y. Then if it is again will coming back propagations. So when it's equal to 1, that is up to that we'll go that progress again and again. So these kind of things you can see in the numerical methods in that mathematics also. Then the precautions to build a predictions of model based on the 5 steps. One is inputs are fed into the processor. The prediction applies weight and estimate the value of these inputs. The prescription computes the error between the estimate and the actual values. These are the so on so. So we are using the free forward mechanisms using the civil engineering problems. For example, how it works means, so I can take that compressive strength of the concrete. I want to design it for the different test datas. I can assign the value of weights 0.5, and 1. It's a multiply by 24 into 0.5 plus 16 into minus 1. I can get that is the output. So this is the constraint. So this value of y is x greater than 0 and x is less than 0. This is the constraint for this function. So this is a linear, is getting 0, is getting like this. Now I can use that tan h sigmoidal tan h function or sigmoidal function. This variation is like this. So smooth variation. For example, my data is here and there. For example, we can getting the data. So different data we have, but we are assuming like this. But we are using the tan sig data. So this is the input, weight, this is a hidden neurons, then activation function. Finally, we can get that output. This is the basic concepts backside of the ANN. How we can apply for that in our problems also. We can take the two input. Similarly, we can give n number of up to xn also possible. So A1 and A2, A1, A2 is the function of W1 the weightages, W2 A1, W21 A2. Similarly, we can A2 also WO2, W12 A1, W22 A2. Similarly, we can multiply it. Simply we can call as A into function of W into activation function is the bias. We can get that result. Again, it's reverse it. You can get the new tested variable using treated functions. So like that, it should be works. Then constitution of experimental database for the beam column joint. The database of experimental reinforced concrete beam column connections will be constituted based on these published literatures. So any ANN or machine learning algorithm, we need the data. We can give we feed the more data, we can get the accurate result. We are constrained the data or less data, the input may not be give exactly at showing this model. So for this, we are constitutions of experimental database. The only exterior beam column joint is selected. So the data is taken by the literature review. The specimens with eccentricity between this beam and columns are avoided. The specimens with eccentricity, the column have the eccentricity is not allowed. So only the axial column numbers is allowed here. The final failure modes will be in the joint. Shear failure only taken consider for this analysis. These are the some assumptions before going to the theory and all. Now I'll come to that beam column joint. Its important factor is the data collection with respect to the scale and name of the specimen, geometrical dimensions of the beam and the column, width and depth, number, diameter and grade of reinforcement bars in the beam, top and bottom, column and corner, locations, length of the beam from joint free to the location where the load is applied, grade of concrete, details of shear reinforcement in the joint location, column axial, load level, failure mode, and all those things. So we are consider these all the data. From this, we can give this input to that ANN. We can get that output for the shear parameters. Now, I want to take few minutes regarding that factors considered from the various design codes. So, ACI code consider compressive strength of concrete, joint width, joint depth, and a factor for the type of the joint. 1, 2, 3, 4 only consider given the formulae to find the joint strength of that particular beam column joint. Then EN code, European code 1, 2, 3, 4, 5, 6. The right joint width, joint depth, column axial load, reduction factor, compressive strength, factor for design of tensile strength of the concrete. Then IS 13920 1, 2, 3. We are considering 3. Compressive strength of the concrete joined with joint depth. New Zealand code, this is. So what I am claiming is also have the different controversies using the number of parameters and name of the parameters and the researchers, empirical equations, all the most of the deviations. Why not we try? We consider these are all the parameters to find the joint shear strength with more complexity. For example, joint width I take in, joint depth I will consider, then compressive strength of the concrete I will consider, beam reinforcement top and bottom, beam length, yield strength of the beam bars, joint shear reinforcement index, column axial load level, beam bar index, beam column depth ratio. These are all the parameters, around 11 parameters. We take an account. This is important parameter to contributing the beam column joint. So how it performs, this kind of things we want to see. For example, the identified parameters as follows. So the joint width and the joint depth, I'll consider some mathematical model like this. Then compressive strength of the concrete FC, the beam reinforcement at the top, take it as TAST, the beam reinforcement at the bottom, BAST, beam length I can take L, the yield strength of the beam bars, F of YB, the joint shear reinforcement index, joint shear reinforcement index. So the reinforcement is horizontal, the shear reinforcement is a vertical. This is the formula, this is ASH, FYH, B, HEFC. This is the shear force formula. Joint shear reinforcement, alpha S is equal to psi high plus psi V. We can use this. Then column axial load level, we can use to here. This is the column axial load level. This formula is available, Turner 2014. Then beam column depth ratio, HB and HC is the ratio. Then joint shear strength, the tau is represented as joint shear force divided by B into H. The tau is equal to shear, the load by area. Load is load divided by area. We can use the JF sub joint shear area. We can get that bond shear strength. Now, we can consider these are the parameter joint width, joint depth, concrete compressive strength, percentage of top reinforcement. These are all the things. You may be raise the questions. So you are, sir, you taken that values different researchers, the shape may be different, then size may be different, reinforcement may be different, then loading conditions may be different. How do you normalize it, or how can ensure the data it's correct for your set? For that, we fix this maximum and a minimum value, mean and standard deviation value also. So width of the joint, it's a varying between the maximum 0.37 and 0.37.1. It's a meter. The meter. Then in case of depth of the joint, 0.42 to 0.15 to 0.42 meter. For example, the compressive strength, the minimum is 50 Newton per mm square and the maximum is a 96 Newton per mm square taken for us consideration. So this is the corresponding mean, standard deviation and all those things, right? So likewise we can take. So this is no algorithm, no restrictions given. Any researchers, according to your convenience, according to your accuracy, you can choose this maximum value, minimum value. You can normalize the data and analyze the data. For this, you can use this the maximum of concrete compressive, the 96. It's a 15. It's not correct, So multiply by this maximum and minima. You can make find this factor from 0 to 1. 0 to 1. Then convert is easy to compare the data. Is occupying less memory spaces also. So for that, we go for the normalization of the data and all those things. So what is that algorithms backside in that ANN? So I can see these are the input, the 11 different input. I can assign the weight and all those things. This is the bias function. Finally, I can get that output, that is a joined shear strength. I can here, this is joined shear strength. So these are all the hidden layers. So input layer, hidden layer, output layer. So how it works with respect to modeling. Then the pre-processing of the data. So how I can process the data? The way in which the data is presented greatly influence the performance of the neural network. I already told. The data normalization is necessary to enhance this network training. Data normalization. Different data normalization method available. So with respect to the data, so you can choose different method also. The maximum minimum method, then psi function, eta function, then different method is available to pre-processing of the data, in particular data normalization. Then normalization of the data dramatically improves this learning speed, or otherwise it take more speed because the more big equation it will be formed, it's taking the more times to solve the problem. The network can be trained in the less interaction. The data is normalized. This is simple method. X is equal to xi into x minima, x maxima minus x minima. Again, we can get this x value. Again, you put xi, x minima, x maxima like this. We can get that data set. We can normalize the data. For this, for example, I can take that joined with then data points. I can normalize the data for joined with then I can represent 0 to 1. 0 to 1, the ratio of joint width by unit length, WL squared by 8, W per meter. This is per meter length. We are represent now. Similarly, I can represent the data 0 to 1. So I taken the different researchers, around 100 researchers I taken. So with respect to that, so which data, for the example, this is a first data. This is data is around 6.65. Then second researchers data 0.4 and one more researchers 0.5. What is this? This is not exactly mapping with our problem. Here also upper bound. This is the lower, this is the upper. So this data it's okay. This data is a fine good. This data fine good. This data it's more or less okay. This data is not good. This data is not good. This data is okay, like this. So the joint width, we have the different variations. The joint depth also, we have the different variations. The compressive strength, beam bars on the top and bottom, a lot of variations with respect to normalizations of data. The beam bars at bottom, beam bars length, yield strength of the bars, joint shear reinforcement, so on so, etc. These are the column set. Then data for the AN modeling. One is a data set, it's important. One is a training data, testing the data, and the validation of the data. Training the data, testing the data, validation of the data. Now I'll come to that activation function. The activation function is an important part of artificial neural network. They decide whether neurons should be activated or not. It's working or not. For example, in case of our marriage function also, no, if any marriage is over, they send this female to their husband house along with some close relatives. There is the key indicators, what they are doing, how they are treating the girl when after that marriages. So that is the activation man. Here like that, we included some activation function. This gives this the function is activated or not. For example, we send one registered post with acknowledgement. It's right. So the acknowledgement card indicates the postal it's maybe reached or not. Same like that. That is the role of activation function. Now come to my problem. ANN modeling. The AN model is developed in some MATLAB in our laboratory. the Evenberg and Mesquent algorithm LM is used applied for MATLAB coding. Find out the best AN architecture, trial and error procedure. We made a lot of Excel spreadsheet also. Performance of this proposed neural network is investigated from the statistical relations like coefficient of correlation, root mean square error, and SI, the scatter index, so on. So this is the formula. We can have the data, input data, output data. So from this, with respect to the CC, coefficient of correlation, the root mean square value, from this data is fitted perfectly or not, we can find. So these are the performance of different ANN architecture. Nodes in the hidden layer, different layer. In case of 4, 5, up to 14 layer. So 1 and 2 it's not perform well. So I am not taken that layer. Then this is the coefficient of correlation value. This is RMC value. This is the training data, testing data, validation for the CC and RMC, right? Training value. So look at with respect to the CC values. So more or less 0.9 it is equal to 1 is a good. 1 is a good. But we cannot achieve the 1 because this is the approximate method. But which layer it's most probably it's closer to 1. So I can take the different layer 1, 2, 3, 4, 5 like that. Layer 12 is the training data, testing data and validation data. It's nearer to that one in all aspects. So 12th hidden layer, 12th hidden layer, it's the best, giving the best performance of these factors. For example, with respect to CC, I can give this number of hidden layers in the 12 here. This is the training data, testing data and validation data. For example, I can take this eighth layer. So in case of training, it's okay. Around 0.9 it will come. So you can take the testing data, the CC values less. So not consider. For example, I can take this fourth label, 0.98 it's okay for the training, but testing data, it insufficient, it's showing 0.94. So these are the things rejected. So this may be take, it's a 12 layer. So what is the in the 12th layer in that neural network? Therefore, ANN 11-12-01 model, which 12 nodes in the input layer, 12 nodes in the hidden layer, and the single layer of the output layer, the optimum of ANN architecture. How we can find with respect to CC and RMC, that layer was good. Yeah. So this is the layer, different layer, 1, 2, 3, 4, 5, 6, different 11 is given now. So I will show that. Yeah, this is. So I can take the 11 parameters like this: BA, BHG, that is at column reinforcement, top reinforcement, bottom reinforcement, length of the beam, the yield strength, and all those things. I multiply different weight W1, W2, W3, W4 up to W1, B1, W1, right? B1, W2, B, W3, BW4, BW5, BW6. Then HCW1, HCW2, HCW3, HCW4, HCW5. For example, PY, PYW1, PYW2, PYW3, PYW4, PYW6. Like this, we can get big matrix. Which combination is the best means the 11th layer is the best. How I can conclude that the 11th layer, the output will come, 11th layer, it's performing best with respect to RMC and CC values. So you may be choose other method also, which layer is giving the better results. So the weight and biases given here, that is a W1, W2, or the weight is connected to the hidden layers and output layer respectively. B1 and B2 is the bias connected to the hidden layers and output layers separately. So This is the W1. This is the W2 coefficients. This is the B1 and B2. We can write the formulae in the mathematical form. W x plus B equal to W into x plus B plus A, right? W into x, it's right. W into x plus B, y equal to mx plus c formula like that. W into x plus B equal to W into x plus B plus A. So this is, then again you go for that reverse process again and again, the result will come. This is the simple process. So we can get that input value different K1, K2, K3, K4 like that. For example, Bj multiply by corresponding W1. The weightage is 0.89, 0.58943. 0.58943. HC is multiplied by 0.19283. 0.19283. Next parameter multiply. This like this, we can multiply all this coefficient. We can take this one. I can take this coefficient K1. Then another coefficient Bj multiplied by 2. This 2 no. So K1, K2, K3 up to K11, K1, K2, K3, K4, K5, K6, K7, K8, K9, K11, K12, K13, K14 like that I can do it like this. That is a coefficient up to K12. Now it's quite difficult to taking this in the different big formulae. I can develop K1 to K12 equation. I have passed through this hyperbolic sigmoidal function. Equivalently, I can take K, the function of K1 is equal to 2 by 1 plus e power minus 2 K1 minus 1. This is the equivalent hyperbolic sigmoidal function. I can y output equal to, for example, John's shear strength is equal to the function of K1. What is the K1? K1 here, the function of K1 and multiply by, that is corresponding factor, then K2 factor, then add these things, finally get this formula. So this is the formula to find the shear strength of the beam column joint with respect to available data in terms of IS code, in terms of previous researchers, in terms of empirical formulae, so on so. After that, you can get that data, the actual joint shear strength and the predicted joint shear strength, how it's correlated with respect to this CC, we can find. Then number of test series, then shear strength. We can take more than 100 data. So how it's various with respect to shear strength and all those things we can get. Then this is the error plot prediction. How much error was occurred, the percentages of error. This also calculated. The 87 percentages of ANN model estimates fall within this 4 percentage to 4 minus 4 percentage to plus 4 percentages error in the range. So this is the, now we can what is the testing MPA and IS code. Then the test result and the ACA code, what is the deviation, how it's mapping, and all those things we can find. Then not only find the performance of ANN model using, I'll take only CC, this coefficient of correlation. Then MAC can take MSC mean square error, RMC can take SI, RMSLC can take. This is related to this more accurate function you can take. So we have the test data. You can find that MSC, SI, and RMASA and all those things. With respect to this also, you can select which hidden layer is the best. So according to that, its answer it's maybe vary. This is not a end; it's a endless mechanisms. You can use that. So similarly, you can use the cost function, optimize W to get the minimum value of joint W, the weightages. Then other methods also we can use to predict the joint strength. Then R square, the Python inbuilt R square software available. Using that, we can find that which one is the best. Then adjust R square value. Then the cost function JW, we can use this predict. Then these are the other methods to predict the joint strength using the ANN. So with this, I want to conclude my talk. So initially, I start with what is the earthquake, what is the problems in the beam column joint, what are the forces acting in the beam column joint, what is the complexity in the beam column joint with respect to horizontal shear force, vertical shear force, hogging bending moment, sagging bending moment, sagging bending moment, tension, compression, then tensile forces, compressive forces, and all those things. After that, I came back for that machine learning. The olden days we can the command. Now we can give the data. So from the data we learn what is happening inside. So we are using that. I used that machine learning algorithm, in particular ANN, how it works, what is the hidden layer, what is the process input output, what is the bias, what is the activation function, what is the uses of activation function. So how form that data set, how to normalize the data, and how to refine the data, how to input the given that MATLAB coding, and what is the output comes from the output, how to formulate that equation, the y equal to mx plus v, like that simple equations to find that joint strength. If it get the data, how to assign the data, or it's maybe reject the data with respect to mean square value, with respect to R square value, with respect to CC. I give an input. What are the other methods to select and reject the some data or output or input and all those things. So from this, today a little bit I learned, we learned also about what are the applications of ANN in that beam column joint. My sincere thanks to my MTech by research student, Strayas Alagundi. He did a lot of work in this work. He is the first, my scholar, started the work in that machine learning algorithm, in particular beam column joint. Following him, one more students also doing that machine learning algorithm technique in the field of civil engineering. This is the first time I started here. I have the less experience also within this stipulated period. I learned something. I discussed what are the things learned in our students. So that's I want to present it here. So thank you very much. This area I want to improve more, and we have the lot of scope. Not only the beam column joint, you can apply for that transportation problem, then water treatment problems, then construction technology, and maximize that production, the industry, production industry, construction industry, even researchers. You can use any kind of problems you can solve using that ANN and machine learning algorithms. So what is the limitations of today? My presentation is I taken only the ANN. According to that, we have a lot of algorithms, other machine learning algorithm are also available. So I taken only the supervised machine learning algorithm. According to that, we have the n number of non-supervised and all those things. I confined with only sigma Dan-sig function, was the bias and all those things. So you can use other function also. We can get that very good result also. These are the limitation of my study. So with this, I submit my sincere thanks to Mr. Salini and Dr. Prabhu, Dr. Maladi, and all other senior professors of Sona College of Technology, and my dear participants all over the world, around 1.5 hours hearing my talk. Thank you very much. Now here we have any discussion regarding my presentation. I can allocate 5 to 6 minutes for discuss about this presentation. within my preview, I can answer your questions. Now over to organization.
Thank you so much, sir. So participants, if you have any doubt, please ask to the speaker. Otherwise, type in the chat box. Please raise your queries if you have anything to ask.
Thank you, Dinesh. Any technical questions? I also learning side. So like a machine learning, you have some input or you give some questions that also may be interpreted in our thesis also.
Or if any participants working on this area, please share your experience also if you are not having any queries.
Thank you, sir. It is very nice presentation. Actually, a civil engineer talking about ANN, which is in the language of civil engineering, so that it is very easy to understand. Normally, the computer science people, when they talk about this ANN, no, it seems to be something vague. But when it is being applied in civil engineering problem and the way in which you explained from basic, it is very interesting and understandable also, sir. Thank you so much, sir. And as you said, there are long way to go with this ANN, artificial intelligence and machine learning in civil engineering. So there are a lot of researchers also need to be done on this area. You have started, and definitely our students project also, we try to involve them in IoT and all, but this ANN part we are lacking little bit, and we will try to implement, sir. Thank you so much for your nice input, sir.
Yeah, thank you very much, madam.
Thank you, ma'am. So before talking as an organizer, I would like to speak as a student now. So I'm so much glad in introducing Dr.T.Palanisamy sir is our guide, mentor, motivator and guru always. So thank you for sharing the theoretical and practical applications on beam column joint, ANN, machine learning and algorithm, and also MATLAB, sir, to all the participants. So I hope the young engineers will adopt this portion on their project definitely, and they're going to create more mathematical expressions also, sir. So
Yeah,
thank you so much for your all-time support for us in academic and also the personal issues we are facing in our lives, sir. Thank you so much, sir. Thank you for your time also, sir.
Yeah, thank you, Shalini and Prabhu and Dr. Maladi madam. Thank you very much.
Thank you, sir.
Can I leave now?
Yes, sir. Yes, sir.
Any feedback sent to my mail, Shalini?
Okay, sir.
Positive
Definitely,
feedback,
sir.
no need. Any negative feedback, please send to me. I will correct it.
Okay, sir. Definitely, sir. Thank you so much, sir. So thank you, participants. Now it's a time for break. The next session will start at 11:30 by Dr. Ajay Chaurasia, sir, which was scheduled on 5th October. So the topic was topic going to be prefabricated structures in construction industry. So kindly all join at 11:30 a.m. again. And one more very important information. Today we have an assessment and also the feedback you have to fill in Atal portal. So please join at 11:30 again and be attentive for the next 2 sessions. We have an assessment and also the feedback filling in Atal. So thank you all. Now you can leave.